Okay, after talking about how to write a quicksort program with ThreadMentor, assuming that you compiled it properly and you type quicksort -min to run it. First of all, the program will ask you for the input array size. Let's say we choose 6 and followed by 6 numbers. After typing return, very soon you will see a screen like that. This screen shows you the developer and the funding from National Science Foundation. Of course, this is a required element, but you really do not have to read it carefully. But I wish, of course, you will read it. These are very, very good programmers in the past. Then simply click OK. Then this is the major screen you might want to look at. This window has some important elements. You don't need to worry about file and option at all for now. The most important thing here is this portion. Hit start, it will start animation, and hit pause to stop animation of executing your program. Hit click step, it would go through all steps in your program. Here, each step is either a thread management, like a thread creation, thread termination, thread join, or something related to a synchronization primitive, which will not be talked about in this demo. Now, then these 3 buttons, I believe in my experience, the most important one is the history graph. Let's open it. For now, nothing is there because a program is not yet start execution because we haven't hit start yet. The next one is thread hierarchy window. The thread hierarchy window simply tells you which thread create other threads. Now, there are some symbols here to understand. A smiley face means running. When a thread is going to join with another, this, and a thread is blocked due to whatever reason is, we won't see this. And suspended, we won't use suspend at all because, as I mentioned, the use of suspend and the resume could be very risky for beginners. And finally, terminated. So let's start running the program. Here, the speed is 1.0, the default speed, but we could change by sliding this slider. So let's run for it, okay? And sooner or later, do you see something happen? Okay, let's stop for a while. So the main program creates a thread called sorting 0 to 5. So this is why we need to assign a thread name to each thread so that when that thread is shown on the history window, you see which thread is the thread you want to find. So here, sorting 0 colon 5 is the name we give to this thread. And why we use 0 colon 5 is because the main program receives an array of 6 elements. In C, the indices would be 0, 1, 2, 3, 4, and 5. Now, at the same time, when we open the history window here, you will see the Windows names listed, history, graph, and the thread hierarchy. Here is very clearly shown the main program created a sorting thread named sorting 0 to 5. And the sorting 0 to 5 create a thread sorting 0 to -1. What does that mean? Remember, we find the pivot elements. The left thread would sort 0 to m-1. The right thread would sort m+1 to the upper bound. Now we'll see a little bit more. Let's resume the execution. But this time, we want to animate a bit faster. So you slide the slider to the left, and then we resume running. So you see, it runs much faster. Let me expand this window to see more. Now, before we go on, let me move it back to 1. So as you can see, main program create a thread to sort from 0 to 5. In 0 to 5, we find the pivot elements. And the left thread sorts from 0 to m-1. The right one sorts from m+1 to 5. So now in this case, the first number is 5. If I recall correctly, 5 is the pivot elements. Therefore, m is 0. So 0 goes from m-1. Of course, the left section is empty. Therefore, the thread is created and terminated immediately. So this one will create 2 threads. Now, the right thread is from 0 + 1 to 5. Okay, so you know this one. Now, reading it further, the sorting thread is supposed to sort 1 to 5 and find the pivot elements, which is 3 in this case, because 1 is used to sort 3 + 1 to 5. The other is created to sort 1 to 2, and so on. Now get back to the history window. This window only shows you who creates whom. But this one shows you how the execution is, what the execution is. So when a thread is run, there is a bar representing running of that thread. In the bar, if it shows green, it means that thread is running. If you see a blue bar, it means that thread is joining, waiting for one of its child thread to complete. Now, as you can see, a thread 0 to 5 creates 0 to -1 is here. Another one is 1 to 5 is here. So the one sorting 0 to -1 runs and terminates. Now look at here. This is the starting time, and ending time of a thread. So each vertical slice is a timestamp. And then sorting 1 to 5 start running, and create a thread to sort 0 to 4 is here, and another one to sort 1 to 2 is here. So what does that mean by this JN? This is a little square. Each of this little square is a tag. For JN, it means join. Okay, if you don't remember, or if you want to know the meaning of this tag, simply go here, help. The help, which shows you all the tag, history graph tag. You click here, every tag, the meaning of it is there. There are many tags. So this means the main program creates a thread. Remember the left one or the right one. Whether you create the right one and run it immediately, we don't know. For an example, in the sorting 1 to 5, and it creates 45 first, followed by 1 to 2. So even though you create and run a thread first, it does not mean that thread will run immediately. But anyway, let's take a look at the main program. It creates a thread and start joining. So where this JN tag comes from, just click the tag. It simply shows you that the statement associated with that particular JN tag is done or is caused by this call. The main program, quick sort thread, want to join because it created a thread and to sort from somewhere to somewhere. And then eventually it would start running it and we wait for its completion. Now, look at this one. The sorting thread 0, 5, create 0, -1 is here. And also 1 to 5 is here. So that means sorting thread 0, 5 has created 2 child threads. 0 to -1, this one, and 1 to 5 here. Now, if you look at this one, it shows you the left sorting thread called join. And if you click on the second one, the right sorting thread is calling join. So now in sorting 1 to 5, sorting 4 to 5 is created, but it runs after sort 1 to 2 is run. So sorting 1 to 5, that's the first, and then sorting 4 to 5 is the first one, and sorting 1 to 2 is the next one. Now, you do not have to run the program in a continuous way. You simply click the step button so that you step through the thread management primitives, create and join terminates, and synchronization primitives, which you don't need it for now. Let's step, it goes for the next one, and next one, and next one, next one, next one. Now, as you can see in the thread hierarchy window, some thread completes it because a red phase would be shown for that thread. And then you keep going. Now, sorting 4 to 5, create 2 threads and complete it. Now, sorting 4 to 5 is created by sorting 1 to 5. So if you continue this, sorting 4 to 5 is done. So now sorting 1 to 5 completes the second thread. So that's the right one. You can expect that sorting 1 to 5 would end immediately. Now you see, it's done. So keep going until everything is done from the main program. Quit it, sorting, and of course the output window on your std out will show the output. Now, the system would ask you, whether you want to close all windows. Let's stop for a second. We could cancel. So you slide this bar left and right. You will see every event that happened in the execution of this program. Or you could extend, you see everything. So this is what would be needed for your program number 3. And you may want to also show thread status. This window is slightly different from the thread hierarchy window because this window only shows you the status of a thread, joining, running, and so on. In my opinion, thread hierarchy may be more useful. So in this way, you are able to see the activities in a threaded program. Now, if you run this program a second time, its thread hierarchy window may be slightly different, even with the same data. Always remember, we create the left and right. In our program, we run the left first and the right second. But the previous run shows you the right thread appears first and the left appears the second. So because of this, if the next time you run this program, the left thread starts first and runs first, the history window would definitely be different. So if you try it with the same data several times, you will see the behavior of a running threaded program could be different from time to time. This would tell you important thing. The behavior of a threaded program is dynamic. A bug appears in this run may not appear at all. And if you do have a bug in your program, you run it for 100 times, that bug may not appear. But the grader runs your program first time, the bug may show up. So it would be much better for you to think carefully and design your program carefully so that you are sure your program is correct, at least by some very careful proof and careful thinking. Now, if you want to kill this thing, you just get back to the main window and click File and quit. Everything would be gone, including the output window, of course. In this way, we end the quicksort demo. I strongly encourage you to download the program. And many programs are on the ThreadMentor tutorial. When you download that program, please do one thing. Remove the .h in the suffix of IO stream. And actually all .h related to C program. Otherwise, you will have so many warning messages. So that ends our demo.